Am I audible? Hello. Am I audible? Hello, Prasad. Okay. My voice is clear. Good afternoon. Okay. Okay, just to be wait 2 minutes also. Okay. Then we start. Just wait 1 2 minutes. Then we will start. You all people, can you see my video? Okay. Okay, just I revise for 1 2 minutes. Then I will start. In the last two class, you, we are studying about colligative properties. And in the class, first two topics I completed in the last class, the pressure, elevation, and boiling points. And today just revision for 1 2 minutes for these first two properties. Then we will focus on numericals. Okay. Then we will go next topics. Okay, guys. I am audible, na clear? Okay. Okay. I just revise first 2 minutes. Then if someone will join, so it is okay. Otherwise, we will go ahead. Okay. If you have any doubts, so please ask me. Actually, yeah, I told it last class. Actually, it is a colligative properties. All our properties are depend only amount of substance, not the nature of solid and solvent. It depend only fully amount of substance. Here, the meaning of amount of substance is number of moles of substance. Okay, and first property is lowering of vapor pressure. In that case, I what happens? Actually, I told you if you have one solution and you have a one uh, if you are comparing the vapor pressure comparing to pure solvent and solution, and that solution if your solid will be non-volatile, so you will observe your pure vapor pressure is more than vapor pressure of solution. You know that. And if I will subtract from pure vapor pressure minus to solution pressure, then we will get lower vapor pressure. Okay. And we know that in the last class I told you how can we express this derivation. So here I will not tell you how can we derive it. Okay. So I just for revision I am telling here. Okay. So that change in vapor pressure, if you find it will be go change in pressure equal to P naught pure vapor pressure into mole fraction of solid. Okay. It means your change in vapor pressure depends on mole fraction of solid. Okay. You can write a mole fraction of solid also like that. The mole of solid upon a and mole of solid plus mole of solid. You know the mole fraction of solid. It is a you know the in the 11th class it is a formula. If in any case if you have any type of solution, it is a dilute solution. It means they have so much water in that solution. So in that case, your number of solvent is more than number of solid. So in that case, you can whenever you need to add a moles of solid plus mole of solid, so you can ignore the mole of solid. Why? Because mole of solid is very small. So you do not need to add add in the denominator side solid plus solid. We just write mole of solid. It is okay, no problem. Okay. And here pure vapor pressure, if you take downside other side delta P downside. So we can write delta P naught minus Ps upon a P naught. It means is a relative lowering of vapor pressure because first upper side is representing the lowering of vapor pressure. Okay, how much vapor pressure will go down, and upon divided by P naught, it represents relative. Okay, is equal to mole fraction of solid, and we can write mole fraction of solid equal to mole of solid upon a mole of solid. Okay, it is a formula. And this formula is very important. If you can observe here, so your relative lowering of vapor pressure is directly upon the mole fraction of solid. Okay, that is why we call relative lowering of vapor pressure is qualitative. Why? Because it depends on amount of source staff. Okay, all people you can see this question. Right? You can see this question. Hello. Can you see that question? This question vapor pressure of pure engine. Hi guys. Okay. So can you please try to solve and then I will try tell you how can you solve it. Okay. Just try. Okay. Just see here the vapor pressure. Just try to solve it, please. Okay. This question depends on relative lowering of vapor pressure. Okay. So if you know the formula, if you understand of the formula, so please try this question. And this question is saying the vapor pressure of your benzene at a certain temperature is 0.850 bar and a non-volatile non-electrolyte solid weighing 0.5 gram. Just 1 second. Okay. Okay, please see. Actually, now I am telling only in the qualitative property. Just I am telling only lowering of vapor pressure. And these topics I cover in the last class. I just revision here. And after revision, after this formula, change in relative lowering of vapor pressure is equal to mole of solid upon mole of solid. Can you try with this question? This question fully depend on this formula. Please try once. Hello. Okay. Solid question. Okay, okay, right. So actually one person joined and now that is why I have to. Okay, you can see. Please see the question. I give you 3 minutes. Just try to solve it up. Okay. Okay. All people, please try to solve this question. This question depends on related ordering of vapor pressure formula. So please all try to this question. Just 2 minutes. Then I will tell you. Yes, yes. Okay. Good afternoon. Please try this question. This question on based on vapor pressure formula. Please try. Actually, during the setting the PDF, now I can't see the message. So that is why I have to go the back. So if you, it is possible if you can speak, so please try to speak up. Okay. I start to telling you. Okay. Answer. Just let me say. Answer is 170 around. Answer is 170 around. Hmm. Sir, some disturbance from vehicle. Okay, okay. Now it is okay, Arshid. Hello, Arshid. Okay. Okay. I start to telling you, okay? Then please focus. That question is saying the vapor pressure of a pure benzene at a certain temperature is 0.85 bar and a non-volatile, non-electrolyte solid weight 0.5 gram when added to 39 gram of benzene and benzene molar mass 78 gram and a vapor pressure of solution is 0.845 bar. So what is the molar mass of solid base substance? Here you have a one solid and one solvent is there because it is a solution. And you, if you focus on the question, you can find it. See here, unknown substance weight is 0.5 gram and benzene weight is 39 gram. You can understand here. See here, unknown substance is a solid and benzene is solid. Why? Because benzene weight more than solid. What happened? Okay. So your weight of benzene here is more than unknown substance. That is why we call benzene solvent. Okay. And you can focus here. In a first line, they mention कि pure benzene vapor pressure is 0.85 bar. Okay, and weight of substance is 0.5 gram and weight of benzene is 39 gram in that question. Okay, they also mention the pressure of solution is 0.845 bar. You can observe here कि in pure benzene case they have more pressure than comparing to vapor pressure of solution. Okay, you know the formula. If we minus the pure vapor pressure minus pressure of solution upon vapor pressure equal to mole fraction of solid, and you know that the mole fraction of solid we can write here mole of solid upon mole of solvent. Okay, I can write here. Okay, okay. If you focus here, your solid if you want, if you put just formula, if you just put the value of in a formula. Okay, what happened? Sir, I'm focusing. Sorry, how to do this problem. Okay, please listen. In the last class, I told you this formula. What happened? Uh, please see. In the last class, na, I told this formula. Okay, that is why I just teaching here a question. Okay, if you try to solve question, so you have get you got idea कि how can you apply this formula on the question. Yeah, yeah, that is what I'm telling. For you, I'm saying कि here we in the last class we study this formula. Okay, that is why today I am now teaching you for question about this formula. Okay, first I tell you concept, then I will start na numerical. So that is why I am coming here. Okay, you want to say something? Okay, please see. In that formula, you can observe here mole fraction of solid is equal to mole of solid upon mole of solvent. Okay. In that case, you know, so we have a weight of substance 0.5 gram. So you know how to calculate the mole of solid. Just divide 0.5 gram by molar mass of substance. Okay, because in that question they do not mention the right mole mass. So that is why you just put molar mass of substance. Okay, and downside mole of solvent is there. And you know mole of here mole of solvent is benzene actually. You know the weight of benzene is 39 gram and molar mass of benzene is 78 gram in the mentioned in the question. Okay, just divide 39 by 78 gram. If you divide 39 by 78, it's come to 1 by 2. So it will go upside here. So 0.5 into 2 upon a molar mass here. And if you focus here, you know the pure vapor pressure is 0.85 bar and vapor pressure of solution is 0.845. Okay, if you minus, you will get 0.005 here, and downside your pure vapor pressure is here 0.85 bar. Okay, if you solve this form, this expression, in the last you will get 170 gram is the answer. Okay, 1 second. Yeah, yeah, I will share you. Okay, no problem. I will share you. Yeah, I will share notes after class. Okay, don't worry. After finishing the class, I will share your notes. Okay, in your parents group. Okay. So in that question, your final answer is 170 gram. And what is the final answer is molar mass of substance. Okay, it's a 170 gram. So you got the answer? Anyone? Can you please tell me? Anyone get this answer? Hello. Hello. Okay, 160 is coming. Okay, okay. I think it is a problem in the calculation. If you try to, you will get 170. Okay, no problem. I will also check one times if you are saying 160. Don't worry. Yeah? But method is same. Okay, okay. After class, I will check again. With the calculator, it is 170, but it is 170. Yeah, okay, okay. You consider the weight of solid also, no, in a mole, I think. Pressure. Okay, okay, that is right. But here no, you can ignore, no problem. But one thing is there, कि in a question when they give you in your exam, NEET or JEE, they will mention a one answer only, 170 or 160, not both option. Okay, so don't worry. If you solve this question, so you will get idea कि around 170 or 160 is the answer. Okay, don't worry. They will show you only one answer, not 160, 170, both they not show. Okay, so don't worry about that. Okay, they will give you very large difference, 250 or 300 like that. Okay, don't worry. Okay. Uh, in last class, I also discussed with you guys elevation and boiling point. I tell you, if your solid is non-volatile and solvent is a volatile, and I tell you one day, volatile, if you increase the volatility nature of solute, what happens? If you increase the volatility nature of any solute, so what happens? Their boiling point will go down. Okay. If you focus in that question, sorry, in this topic, you know that if pure vapor pressure is greater than pure vapor pressure of solution. So if you comparing here, you will get to know कि your temperature your boiling point for solvent is less than boiling point of solution. Why? Because your solvent actually is a pure air, and solution solid is a non-volatile. Okay, that is why your vapor pressure so it will be greater, but your boiling point is less. That is why we can write here. Yeah, I also discussed this thing in the last two class, so I just revise here only. If you have any doubt, so you can ask also after 5:15 on Monday. Okay, don't worry. Your boiling point for solvent is less than temperature of solution. Okay, if you minus this, okay, so you will get if you minus temperature of solution minus temperature of pure solvent, so you will get delta T, and delta T we call elevation in boiling point. Okay, this delta T elevation in boiling point actually is directly proportional to molality. Okay, if you remove the proportionality, so you will get Kv constant. Okay, this Kv constant we call molar elevation constant. Yeah, sometimes we also call Eulenscopic constant. Okay, this Kv value are different for different solvents. If I have different solvents, so I will also get different values. Just like for water, if you know for water Kv value is 0.52. So like that. If you take other liquid, so it also different value. Okay. Please, you think, yeah, one person asked me in the last class, sir, why delta T directly proportional to M only, not molarity, not mole fraction, not mole Y? You say something? Yeah, yeah, I tell you. Actually, this role scientist, this role scientist is there. He's doing so much experiment, okay, colligative property. So he's doing when he is doing experiment, so it will get your delta T is it it got that time the delta T is very related to molality, not molality or mole fraction. I think this result is directly depend on the experiment, not mathematical expression. Okay, so this expression you can get from experiment, not derivation. Okay, so he noticed that the delta T is very close to molality. That is why he take in the formula molality only. Okay, not molality, not mole fraction. Okay, and then it remove the proportional, and it will put the kV value. Okay, and this kV value different for different solvents. Okay, if sometimes in the question the GE and it, they will sometimes they will ask what is the unit of kV. So you can find also like that. If you divide delta T by molality, you get kV. You can find here units of we can do in our chemistry lab, sir. No, no, it is not easy. It is not easy. It is not as easy as we can't do in our lab. Okay, please see. Actually, here if you divide delta T by molality, so you will get kV, and you will get here kV value, kV unit. Okay, but something saying anything.
Who done that experiment, sir?
Rod scientist is there, no? In a solution actually is a Rod's law. Is a scientist. He just try to explain every concept for colligative property. He's try to all for okay all constant values coming from actually experiment. Okay, then after he just prove it. Okay, you saying something?
Yes, sir. Asking that question.
Okay, okay. So I am saying that all this formula are there. No, they are just experiment. Okay, and after experiment they will get this thing. Okay, it's not a mathematical expression. Something saying something. You will get notification again again. Okay, sorry. So this elevation in boiling point and depression in freezing point, this both concept is based 100% on experiment, not mathematical. Okay. So why he put a molality here? That is why because delta T is very close to molality value, not mole fraction and molality. That is why he put molality here. Okay. And chemistry experiment, if you are looking for chemistry experiment, is very difficult because for this thing you want very standard things, and it is not possible in a lab. Okay, so in sometimes in a JE unit they will ask a kV unit. Okay, if you divide by delta T by molality, so you will get units here. You know here your what happened, please see your change in temperature air na always in a Kelvin, not a degree Celsius. Okay, please take care over here. Here you in this formula your delta T is always in a Kelvin, not a degree Celsius. Okay, and molality, mole per kg. If you can write here, if you can try to solve in your copy, so you will find it. You just Kelvin upon a mole per kg. So if you can simple, so you can say here Kelvin into kg into per mole. Okay, it is a unit of kV. Okay, delta T is equal to kV into m. If I will write a molality like that, number of solid upon a weight of solvent in kg. Okay, and a mole of solid you can write like mole of solid upon a molar mass of solid. If your solvent in a gram, then you have to divide by you have to multiply by 1,000. If your solvent in a gram, you have to multiply by 1,000 in a percent. Okay, and delta T is T solution minus pure temperature. Okay, for dilute solution, I am telling you, if in a solution you add a liquid or you add a water so much, so for that thing you have molarity and molarity is same. Okay, molarity and molarity is equal to same for dilute solution. Okay, because why? Because for if you adding the water na, so what happen, your number of solute na will go down, and your amount of solvent na is very increasing. So that is why your amount of solution या amount of solvent is equal. That is why we consider कि molarity and molarity will equal for dilute solution. Okay. For water, you have to remember this value is 0.52 kg kilo per mole. Sometimes they will give you, but sometimes they will not give you. That is I am saying because water is very common thing. So just please remember it. Okay. And this question is depend on this formula completely. Can you please try, all of you? This question, can you please try? Hello guys. Hello. Can you try this question, please? Okay, okay. Okay, I will give you 2 minutes. In just 2 minutes, you will just try. Just try. This question depends only formula. Okay. Anyone got any answer? What answer you got, answer? Okay, okay. No problem. Okay, please just try. No problem. Okay, okay. How much answer you get? Both Harshit and no? How much answer you got? Just tell me. 196. That's why. Okay, I just I think. Not 2.88 gram. You are confusing any question data? Please see. I tell you no problem. I think you miss I think some value here. I think question. Please see. In a question they are saying calculate the mass in grams of impurity of molar mass 100 gram per mole which would be required to raise the boiling point of 50 gram of chloroform by 0.30. Okay, okay, it is right, Harshit. You can also write only 2.88. Does not need to write so much value. Okay, let's understand. In this question, they will ask, please tell me how much solid you can be added in a chloroform. Okay, and chloroform is their mass is 15 gram is given in the question. If I added a chloroform, if I add some solid in a chloroform, so what happens? Their boiling point will be increased. How much? 0.30. They mention that delta T is 0.3 Kelvin. Please understand one thing. If I'm saying about temperature difference, so temperature difference for Kelvin and degree Celsius is the same. Okay, no problem. That's all. Please understand one thing. If I'm talking about the temperature difference, so then your temperature difference of Kelvin and degree Celsius is the same. Okay, so don't worry if he's saying if in this question they will mention 0.30 Kelvin is okay, but sometimes they will say in a say degree Celsius, so it is not a big problem. Okay, you can consider also Kelvin. Okay, so temperature difference in Kelvin and degree Celsius is the same. Okay, delta TV, you know the formula delta TV is equal to kV into m. You know the molality formula, number of solid upon mass, number of moles of solid upon mass, weight of solvent. Okay, if I put delta TV here, if I put here delta TV value is 0.30 and kV value is a question they given you 0.52 and weight of solid you have to find here, and for solid they will give you molar mass 100 gram per mole. You can put here. Okay, and upon downside you see weight of solvent, and weight of solvent is given 50 gram. So you can put here. You can see here, here weight of solvent in a gram. That is why we multiply by 1000 here. Okay, weight of solvent actually here in a gram. That is why we multiply by 1000. If you solve it this expression, you will get 2.88 gram. Okay. Anyone confusion in this question? Now, please tell anyone. Anyone confusion in this question? Okay. It is okay to teach in a PDF. You are understand? Understand? I am teaching in a PDF. You have any problem because I'm teaching using the PDF. Okay, put in full screen. Okay. Now it is okay. Now Archit is okay. Actually, I increase the size. What happened? Just tell me what happened. Now it is clear, no? It is coming in a big screen. Hello, Archit. Okay. Okay. Now you can try this question. This question, 18 gram glucose is dissolved in 1 kg of water in a saucepan. At what temperature will water boil at 1.013 bar? Kv value for water is 0.52. Can you please try? I tell you one thing here. here I mention only pressure. Okay, 1.0313 bar. That means it's the atmospheric pressure. You can consider it is a normal atmospheric pressure. You can consider कि water boil at their boiling point. Okay, so you know the boiling point of water, all of you. You know, if I'm saying कि boiling point of water is 100 degrees Celsius, so for 100 degrees Celsius, we have to put one same pressure. So this pressure is given here, 1.013 bar. This at this pressure, your boiling point of water is 273 degrees Celsius. Yes, and a Kelvin is 372. No, 373. 373. Yeah. No, you have to put 373. Okay, no problem. Yeah, 372, 373 is very nearest. So please understand, at this pressure, na, your boiling point water is 100 degrees Celsius. Okay, so you just understand this is a normal atmospheric pressure. Okay, yeah, 372.948 is equal to 3.73. Yeah. In your exam, you cannot take this value so, in a fraction. Please try to solve it. Just 1 second. Yeah, it is right. Answer it is right. Okay, I tell you here. Okay, yeah, Prajul, it is right. Okay, I'm telling you here. Actually, here they mention if we have 18 gram glucose, we dissolve in 1 kg of water. Okay, in a water saucepan. At what temperature will water boil at a 1.013 bar? Actually, it is the atmospheric pressure. That is why we consider that boiling point water is 100 degrees Celsius. You can consider it. Okay. You know the delta T formula is kV into m, and m is a molality here, a weight of solid upon a molar mass of solid into weight of solvent. You can write here, and you can see here we take weight of solvent. Just see here delta T we can write here TB minus T naught B. T naught B mentioned there is a pure vapor pressure of water only. Okay, and as a TB is mentioned here, boiling point of solution. Okay, so you know the boiling point of pure water is 373 degrees Celsius. Sorry, 373 Kelvin. All of you know. Okay, if you add 273 plus 100 degrees Celsius, you will get 373. 373 Kelvin is a boiling point of water. So we can write it is a pure, pure, pure. You can write here. Okay, T not B. And now can you put here value? Kv value is given here 0.52, and weight of solid is given here 18 gram into 1000, and your molar mass of solid is a 180 gram, because you know glucose molar mass is a 180 gram, and weight of solvent is mentioned here 1 kg. If you take 1 kg or gram, it is same thing, because it is no any problem. Okay, you will also take 1 kg, no problem. Okay, if you take in a gram 1000, so you will multiply 1000 by. If you multiply here only 1, so you just not multiply by 1000. Okay, it's the same thing. If you divide 180, so you will get 0.052 here. If you solve this side of expression, so you will get in the last 0.052, and you know that T naught B is a 373 here. If we go that side, so it will become 373.052. Okay, so your boiling point temperature for solution is 373.052 Kelvin. So it is the answer. I think Prajwal Arshit and Faiz, you all are right. Okay. Now I am teaching you osmotic pressure. Okay, guys. This um, I am teaching you now osmotic pressure. Okay. Before the osmotic pressure, I tell you one thing. Actually, in the solution, what we doing? We have on a container type. You can see in the PDF. If we have a container, okay. In a between the container, we have a one filter paper is there. One type of filter is there. We just call this filter semi-permeable membrane. Okay. And this filter left side we have a pure solvent A, and the right side we have a solution A plus B. And in the solution A is the pure solvent, but B is a non-volatile solid. Okay. And you understand why I'm mentioning a semi-permeable membrane. It is a why it is a semi. It is a meaning that this filter now is allow only one component only for solution to pass. This type of filter just allow only one component only. So here in this case, they allow only solvent particle to move. Okay, filter, not solid particle. So here in the solution, solid particle do not move. Only here in that container, only pure solvent particle are moving. Okay, that is why we call semi-permeable membrane. I am also write here definition of it. When membrane is a permeable to solid particle but impermeable to the solid particle, they are called semi-permeable membrane. We call in a shortcut SPM. Okay. So here only solid particle can pass this filter, not solid particle. Okay. And please see. And left side is a pure solvent. The solution is the right side, A plus B. And I'm telling you it. The pure solvent concentration is very less because here only solvent is there. But side you have a solid plus solvent. That is why in the right side you have concentration is very high. Okay, and left side your concentration is less. Okay, because here left side you have only solvent and right side you have both solid plus solvent. That is why right side your concentration is very high and left side concentration is less. Okay, what happened here? Actually, you see this topic here, osmosis. Actually, osmosis is a process, not anything. It is just a process. What is the meaning of that? If your pure solvent particle, if your pure solvent particle is just moving from pure solvent side to solution side, okay, through the SPM, okay, that this type of process we call osmosis process, okay. And here only pure solid from pure solid left side, the pure solvent particle is there. It's just moving from to solution. Don't think like that. So in a solution, you have also pure solvent A, which is also moving now. Only pure solvent side, your A particle is moving. Okay, to right side. Okay, so this process we call osmosis. Okay, actually, just see here. In pure solvent, I told you just 1 minute ago, is a low concentration or solution is actually high concentration. And I tell you already, the only pure solvent particle A is moving to right side only. Okay. If if I apply the pressure on the right side, solution side, okay, and perpendicular direction here, you just see here in a corner of the solution. If I apply the pressure here in the solution side, so what happened? Whatever the pressure of flowing the fluid now from pure solvent to solution, it will decrease. And I apply the pressure and I increase the pressure. At what time? What happen after some time? Your applied pressure on the solution side, and your whatever the pressure is, what the pressure of flowing liquid from pure solvent to solution, it is become equal. That is why your pure solvent does not move the solution side. It is stopped. Okay, that pressure we call osmotic pressure. Actually, osmotic pressure is actually hydrostatic pressure. Why? Okay, because here your liquid is a hydrostatic nature. That is why we call hydrostatic pressure. Okay, and the osmotic pressure we built only solution side. Okay, right side only, high concentration side, not pure solvent side. Okay, okay. What is the meaning of hydrostatic? Just understand. In a container, if your particle is not moving, if it If your particles not moving, it will be called hydrostatics. Okay, statics means it's not moving. Okay, yeah, it is not accelerating also. Okay, and not feel not here you just consider like sorry here to particle will move now pure solvent to solution. I know it is moving, but it's very slow. That is why we do not consider it is a moving fluid. Okay, don't consider it is a hydrodynamics. Okay, it is hydrostatics here. Okay, so what is the meaning of osmotic pressure? When you apply the pressure on the right side, solution side, and due to this, your movement of your solvent to right side it will stop. That we call osmotic pressure. Okay, osmotic pressure we just applied for stop the flowing from pure solvent to right side. Okay, it's like that. If you apply the pressure, it will become osmotic pressure. What is the meaning of that? They stop the flow. Okay, if you just think, if I apply more than pressure of osmotic, so what happens? So what happens? Your now during the osmotic pressure, your pressure of pure solvent, the pressure of solution side it will be same. That is why flowing stop. But you apply more pressure on the solution side. So what happens? Your left side, pure solvent side, your pressure will go down, and your solution side pressure will go higher. That is why your fluid is start to moving through the SPM from right side to left side. Okay, with this called is reverse osmosis. When you pressure applied on the solution side, it is greater than osmotic pressure of solution. Then we call reverse osmosis. Okay, what is the meaning of reverse osmosis? When you apply the pressure more than osmotic pressure, so what happens? Your solution side, your pressure will be higher than comparing to pure solvent side. That is why your fluid particles start to moving through SPM. But just understand, if I apply the pressure more than osmotic pressure, so your only A particle is moving from A solution to pure solid, not B. Okay. Don't think like that. If I apply the more pressure, so your B particle is also moving. Not here. Only A particle is moving. Why? Because in SPM we using they are only allowed only A particle, not B. So just clear is that if I apply whatever the pressure is more than osmotic pressure, but your B particle is not moving across the screen. Okay, only A particle is moving, is a solvent particle only. Okay, that we call reverse osmosis. Actually, whenever you see water treatment plant is there in India, we are using, and that plant now we are using this concept. Okay, actually in our India, in so much city, we have this type of industry. We have water treatment plant. They are using this type of function. Okay, they are working on this concept. What they are doing, they put one side pure solid. They just put one side is a wastewater. Okay, then when they apply the more pressure on wastewater, what happens? So in the wastewater, whatever the water is pure, they will just come out because of high pressure. Okay, on this basis of concept, they are using they are just filtered the water. Okay, and isotonic solution. What is the meaning of isotonic solution? Till here, you have any doubt? Whatever I teach in osmotic, you have any doubt? Anyone? Okay. Okay, don't worry. Yeah, after class, now I will upload this notes in your group. Okay, and NEET and JEE both. Okay. What is the meaning of isotonic solution? Actually, if I have a two solution, okay. If I have solution A and I have solution 2, what does one? You want to say something? Let's see. What happens if I have two solutions, solution 1 and solution 2? In both for both solutions, if I have same osmotic pressure, we call isotonic solution both. If I have solution A and B, and both solutions have same osmotic pressure, so we call both solution are isotonic solution. Okay. And sometimes they will ask in your board exam, what is the difference between the hypotonic solution and hypotonic solution, not a J and E. Okay. In a board exam, sometimes they will ask you the osmotic pressure. What is the osmotic pressure? what is the meaning of hypertonic and hypotonic. So what is the, just understand here. Actually, hyper means more. If you understand what is the meaning of hyper, it is means is a more, and hypo means minimum. That it meaning is if you have two solution and both solution they have a osmotic pressure pi 1 and pi 2. If your pi 1 pressure of osmotic pressure of one solution 1 is greater than osmotic pressure of 2, so we consider it the solution 1 is a hypotonic solution. Why? Because it's a uh, osmotic pressure is higher than comparing to two solution. That is why we call one solution is hypotonic, and which is a minimum pressure comparing to other, that is hypotonic solution. Okay, so here you have to focus here. If you have one solution have higher osmotic pressure, that is one solution is hypotonic, and two solution have minimum osmotic pressure, that is we call hypotonic solution. Understand here? Till now you have any confusion? Isotonic, hypertonic, or hypotonic? If someone have confusion, don't worry. If you do not ask here, no problem. So we also clear in a Monday, okay, after 5:15. Okay. Now I just give only theoretical, okay, related to osmotic. Now just we come at a mathematical expression, okay. So please focus here. I tell you one thing. Actually, osmotic pressure formula, you know that in your book they mention CRT. Okay, what is the meaning of C? C is the concentration solution, and R is a universal gas constant. No, no, we can't say here universal gas constant. It's a normal gas constant. T is the temperature. Okay, but this formula is coming from PV is equal to nRT equation. You know that PV is equal to nRT is the ideal gas equation we are using for ideal gas. Okay, so this formula is coming from this. This formula is phi is equal to CRT's formula is coming from PV is equal to nRT. Okay, if you take now PV that side n by b, you know that mol n upon volume, it is a molarity is there. You know, mol upon volume is a molarity is there. That is why we mention here C. Okay, and RT. So this and P pressure is be written here pi. No problem. You have any class? You have any class? Please tell me.
Yes, sir.
Okay, okay, physics class. I
No,
think you
sir.
have.
From another
Oh,
institute.
okay, 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 okay. I take from a mathematical expression Monday. Okay,
Bye, sir.
okay, okay. Bye. Okay, guys. From mathematical expression, I will continue from Monday. Okay. Till now,
Guys, bye.
theory. Hello. Okay. So from mathematical expression of osmotic pressure, we will continue Monday. Okay. So if till now, whatever I teach today, if you have any doubt, so you can ask me now. What do you want to say, Prajwal?
Sir, share PDF.
Okay, okay. I share after class. Don't worry. After class, I just share in your group. Okay.
They were asking some focus.
Okay, okay. You can go.
Bye, sir.
Okay. I think your physics class also is there.
Six, sir.
Okay, 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 okay. Actually, Prajwal, Arshit, because I am teaching here na, with the help of PDF. Okay, so that is why I can't give you numerical so much here in now. So don't worry. In if Monday we take also extra class. Okay, after 5:15, yeah, yeah, during the class we will solve the numerical. Okay, because here so it is difficult for me. Okay,
Hari
because
Gandhi understand. Gandhi.
okay, okay. If you have any doubt till now, you can ask me. Yeah, otherwise you can leave, no problem.
Hari Gandhi entra.